Hello everyone. So today we are solving another question of JEE Advanced 2021. So this is from the topic of atomic structure and you must know some of the concepts to solve this question. So let's discuss the concepts first. First of all, you should know that there are some energy level exists within an atom, like if we call this is n equal to 1 or the ground state. Then comes here n equal to 2, n equal to 3, n equal to 4 and so on. We can go up to n equal to infinity. In between there can be so many lines. So what do we call of them? Like if we mention n equal to 1, n equal to 2, n equal to 3. So we have some name of these energy levels called as Lyman, Balmer, Paschen, then bracket and P fund, which are not required in this question. So let's see how we can solve this. So our first option asks the ratio of the longest wavelength to the shortest wavelength in Balmer series is 9 by 5. So when we can judge that whether the wavelength is longest one and the shortest one. So for this, use just this much. We know that what is lambda given by a formula. 1 by lambda is equal to nothing but R by 1 by n1 square minus 1 by n2 square, where n1 is here fixed for each energy level. Like if we say we are doing for the Lyman series, so n1 will be fixed as 1. We are saying if we say we are doing for Balmer, then n1 will be fixed as 2. So when we can get the shortest wavelength in Balmer series, we can get the shortest wavelength only when we will put n2 as an infinity. Then we will get the shortest wavelength, and then when we can get the longest wavelength, we will get this only when we will like the electron will jump from just one energy level above. Okay, so if we do this, so for longest, lambda longest, it will be equal to nothing but, I think this will lambda longest for this will be equal to 1 by r and 1 by 2 square minus 1 by, just if we get, then we can get is 3 square. This is nothing but if we take 9 minus 4, that is 5, and 36 by 5r. And if we try to find lambda shortest, it will be equal to 1 by r and 1 by 2 square, that is nothing but 4 by r. Now we have to find the ratio of lambda longest by lambda shortest. So we can clearly see 36 by 4 is 9, so 9 by 5. Hence our option A is correct. And let's move on to option B. So it says that there is an overlap between the wavelength ranges of Balmer and Paschen series. So how we define overlap here? Let's suppose if for the Balmer series, the wavelength varies from 0 to 100. Let's say it varies from 0 to 100. So it will only overlap to Paschen when Paschen will have something like 90 to 200 or 85 to 200, but it will not overlap when it will start from 110 to 200, something like that. I hope like this range problem is clear. So what we will do to prove this, let me first erase all this. What we can do to solve this is we will find the longest wavelength of Balmer and the shortest wavelength of Paschen. Because as we seen, like if 0 to 100, so we will find this value and we will find the shortest value of Paschen. So we will see whether they overlap in between or not. Okay, whether it is less than or more than. So we can judge by that. So what is the longest wavelength of Balmer? It is nothing but 36 by 5r. And what will be the shortest wavelength of Paschen? It will be nothing but lambda shortest of Paschen is equal to 1 by r 1 by 3 square, that is nothing but 9 by r. So we can see that 36 by 5r is clearly smaller than 9 by r, as 5 by 36 by 5 is nothing but 7.2 something. So it means that where it stops, it starts from further ahead from 7.2. It means there will be no overlap, hence our option B is incorrect. Now given C, the wavelength of Lyman series is given by this and this. Lambda naught is the shortest wavelength of the Lyman series. So what will be the shortest wavelength of a Lyman series? It will be nothing but lambda shortest Lyman. It will be equal to r and then 1 by 1 square only. So it is, sorry, it will be 1 by r. Okay. So lambda shortest is equal to 1 by r. Now we have to calculate for all those, for all the all m value in the Lyman series in making formula with this only, lambda shortest. Okay. So we will write lambda m is equal to 1 by r 1 minus 1 by m square, as it is coming from mth energy level. So what lambda m will be, 1 by r is nothing but lambda naught. So lambda naught by 1 minus 1 by m square. Is this the same given in our option? No, it is different, as it is given by 1 plus m square, and it is also in the numerator, so this formula is incorrect. Hence option C is also not right. And D is the same question as B. We have just changed in series Lyman and Balmer. Again, we just have to find the what is the longest wavelength of Lyman and shortest wavelength of Balmer. What is the longest wavelength of Lyman? It will be nothing but lambda long of Balmer will be equal to 1 by r 1 minus 1 by 2 square, that is 4. So 4 by 3r. Okay. And what will be the lambda shortest? It was like found earlier only, it is 4 by r. Again, we found that it is very much small than 4 by r. Hence, we can say that there will be no overlap. No overlap. Hence, our option D is also correct, as it says that they do not overlap. So let me write the final answer. Nothing but A and D. Thank you, everyone.